Welcome back to the channel. In this video, we're going to walk through how to use GitHub Actions to automate the deployment of our application to AWS. In the previous video, we had to manually build the Docker images locally using Docker Desktop, push them to ECR, and then update our application by having the ECS service pull those updated images from ECR. We didn't do it in an update sense, we did it in a deployment sense, but we wanted to update, we'd have to follow that process. So in this video, we're going to take that all away. We don't have to run Docker Desktop for this video because we're going to use GitHub Actions. This allows us to have all the Docker build for the Docker images happen in GitHub Actions, push it to ECR, have the ECS service pull those updated ECR repositories and updated task definitions automatically, all within a single script file that we're going to create. And beyond just simply saving us time, it also does a very important thing of standardization. You don't have to worry about copy and pasting commands or manually typing them, even worse. Every single time, you would all standardize all configurations set in a single file. This is great for yourself because it prevents you from making mistakes by doing subsequent updates to your application. But it's even more powerful in an organization because this allows you to have a standardized file for updating the application that many users in your organization can use. So you don't have to worry about different people have different interpretations. Everything's very standardized. So we're going to see that in this video. Now, real quick before we get started though, you know I'm out a lot by doing a few simple things. Subscribe to the channel is one. That really helps me out a lot. Liking this video and sharing on platforms you use like Reddit, LinkedIn, etc. Starting this repo. Follow me on GitHub. The way you can do that, you can click the little icon right here. It'll take you to my page and just click follow. That helps out a lot too. And finally, sponsor me either on GitHub sponsors right here or scrolling down the repo right here on Patreon. One time, recurring, $1, $10, whatever you want. Anything helps out a lot. I'd really appreciate it. Okay, with that being said, let's get into the video. First thing, if you haven't been following along, you want to clone the repo. You have it right there. Git clone, paste. So you have it saved locally. Open up your favorite code editor. I'm going to use Visual Studio Code. So we're going to be looking at 4 different files in this video. Now, one thing I want to preface real quick. If you've been following the video series, great. You have all the components created on AWS already. If you haven't been following along, you're watching this video for the first time, if you don't have the ECS service, cluster, etc. already created on AWS, when you try to run the script and update those existing services, they don't exist, it will fail. So make sure you have these services created. And make sure they're created with these naming configurations. If you don't follow these naming configurations exactly, then you have to change them in this file as well. Because they're trying to key off the names that I provided right here. And that's why we reference this file using these names whenever we create our components throughout the entire video series. It's finally coming full circle when we're seeing why we're using these naming conventions. Okay, so with that being said, let's go through this file first. Where can you find this file? In the .github workflows folder, aws-ecs-deploy.yml file. Great. This is the file we're going to run on GitHub Actions to automate the deployment of our application to AWS. And by deployment, I mean update in this video. First thing we're going to look at is this on. What does this say? It says workflow dispatch. It's the only one that's uncommented. This is saying that we can manually run this workflow, meaning you can manually trigger updates to our application. Now, you have the option to uncomment these as well if you want. This is for releases. So whenever you publish a new release of your application, going back to GitHub right here, you can create a new release. So every time you create a new release, you would actually automate the update of your application on AWS. It's a common use case, one I actually use myself quite often. You also have it on pull requests, where you specify specific branches you want to have it run on. So if you make a pull request to a sub branch, maybe you don't want to update the application. You only want to update the application, we make pull requests to the main branch, for example. So if you comment this right here, this workflow would run automatically when you make pull requests to main. So these are options you can play around with. I'm giving you a lot of optionality here, but we're just going to focus on the workflow dispatch for this video. Name, nothing important, call whatever you want. Here's the jobs. So there's nothing beyond jobs. This is where you specify everything that happens in the application file. So we have deploy. Again, the only thing that happens. Now, name deploy. We're running on Ubuntu latest. What's the other option? Windows. Why are we doing Ubuntu? Lightweight, faster. We don't need Windows. If you don't need Windows, don't use it. Environment. So we're specifying all of our environment variables. These are all the variables we're going to reference in this script later on. One example right here, env.aws default region. It allows us to easily specify them all at the top of the file and then reference them within the file instead of having to copy and paste a bunch of different times. So we want to update this, say nginx-2, it would update everywhere it's referenced in the script rather than having to do it copy paste every single time it's mentioned. So that's why we specify all these up here. If you watched some previous videos, you're more than familiar with this. Real quick, 2 ECR repository names, the ECS cluster name, service name, and task definition name. There's one of each. And then within the task definition, the names of the 6 containers that we're running. nginx, Flask, RabbitMQ. You can also substitute Redis if you want. Celery Worker, Celery Beat, and Celery Flower. Great. Our default region, US East 1. If you're in a different region, change this here. Image tag, I'm just using github.shaw. This gives us a unique tag for each update we make to our task definition and Docker image. If you want to use something like latest instead, you absolutely can. No big deal. Docker image RabbitMQ and Docker image Celery Flower. This is because we're not building custom Docker images for these two, pulling them directly from the public Docker Hub. So we just specify them right here. Great. Now we move on to our steps. So this is where we actually run our code. First, we check out the code from our main branch. So we have our code. Now we're configuring AWS credentials. We're doing our secret AWS key ID and AWS secret access key. And we're specifying our default region, which we specified already up here. Again, change if you need to. Where are these guys coming from? Well, we need to get them from an IAM user. Now, you may have one already created with appropriate permissions, but maybe you don't. But let's go ahead and create that ourselves right now. What I want you to do is I want you to go to IAM, users on the left, and then create a new user. The 4 different permissions you're going to want to assign are these 4 right here. EC2 container registry full access, EC2 full access, ECS full access, and this long one ECR container builds. Now, if you don't have all 4 of these, it probably won't work. Now I'm giving full access here. Obviously, this isn't the best case. You probably want to limit it in a real production sense. But to make things just a little simpler, I'm just giving full access. You can make these a little more specific if you want on your own time. But for this video, these are the 4 you should have. Great. So going back. So we have to specify these secrets AWS access key ID and secrets AWS secret access key. But if we do a Control F, you see they're referenced, but they're not defined anywhere. Why is that? Because we don't want these values hard-coded in our file. Because if they were, that means if this file was exposed or we want to share the repo with an outside party, they would immediately see our access key ID and secret access key, giving them unfettered access to the permissions that we assigned for that IAM user. That's bad. So what do we do instead? GitHub solves for this themselves by having something called secrets. So you go to the repo, you go to settings, and you go to secrets and variables, actions, and now you can create your 2 secret keys they're going to reference. Now they have to line up exactly. So going back to our file, scrolling down, AWS access key ID, you would go there, come back, close it right now because you don't need it anymore. New repository secret, paste, and you would paste the value. Where do you get the value? We're in our user, security credentials. You're going to create an access key. You're going to do third-party service. I can understand. Next. I'm just call mine test because I'm going to delete it right after. Create access key. And you see your access key and secret access key. This is where you get these values from. So you copy and paste. Copy, paste. I already have mine, so I'm not going to click add secret, but you would. New repository secret. And do the same thing for AWS secret access key. Name, secret value, right here. And then paste. You click add secret, and you're all set. Now for myself, I just exposed my AWS access key and secret access key. Really bad. What would you do if you accidentally did this? You go down to your, when you expose, you just click delete, deactivate, and then confirm deletion. You just copy and paste, and boom, all set. It's gone. So even though I exposed my secret access key and secret key ID, they're now gone, so they can no longer be used against me. So that's how you would handle that specific scenario. So you see these 2 values right here in your secret keys for your GitHub repo. Once you have those set, then this will work fine and be able to access these values without problem. So going on, What have we done? Configured AWS access credentials. Great. Now we're going to log into ECR. Just calling these AWS actions, AWS Amazon ECR login main. This is an AWS action created directly by AWS and Amazon. So they provide this for us. Great. Now we're going to build, tag, and push the image, the Docker image, to Amazon ECR for nginx. We're not building the image locally on our desktop anymore. Great. We don't have to run Docker desktop. It's all happening within this GitHub action. Saves us a lot of time, saves a lot of computing resources we need for our local machine. It's fantastic. Build, deploy, image, ECR, nginx. Just create an ID because we're going to reference the outputs later. And we're using this custom built GitHub action created by another user, Wohan. What this does, in addition to a simple GitHub action just building and pushing the ECR image, is creates a separate repo with the same ECR repository name with dash stages afterwards. Why is this? Because it actually caches certain elements of the build of the Docker image to save time on subsequent builds. If you got a simple Docker image like this Docker file nginx, that's building an image that's very small, very simple, not complex at all, not many steps, not many dependencies, that's probably overkill. But in real world scenarios, you're not going to have 1 or 2 dependencies. You're going to have 30, 40, 50. You're going to have not just a requirements file, but have dependencies like a Postgres or something else as well, or another DB like MySQL. So in that case, you absolutely want to have these dash stages. So in that case, you definitely want to have this dash stages repo to make your subsequent builds much, much faster. So that's why we're using this Wohan Docker build. We specify a few different configurations, the username, the access key ID, the password, same thing. Login ECR. Where's this login ECR coming from? Right up here. This is why we have this ID. The ID allows us to reference previous steps. So we can put it right here, outputs.registry, image name, we're getting it from right at the top, the env file, image tag, again, coming from the top, and we have to specify the Docker file. By default, it uses just Docker file. So we didn't have this here, it would try to look for that. But the Docker file nginx is different than the default Docker file we use for the Flask, Celery worker, and Celery beat. So we have to specify it here. And this push images and stages true. Again, this is what I just said, the dash stages to make it faster for subsequent builds. Then we do the same thing for Flask. We don't need the Docker file because we're using this just default Docker file right here for Flask. So we don't have to actually specify it on here, but everything else is the same, except we're using a different env.aws ECR repository named Flask Celery. Great, so we just updated both of our ECR repositories. What's next? Now we're going to update each one of the containers in our task definition, our ECS task definition. Remember, we have 6. So for each one of those, we're going to update each one. So we have to specify this task-definition.json file. Where is this coming from? This is actually coming from AWS. So what we need to do is we need to go to our task definitions, select the task definition, click the latest revision, scroll down, JSON, then download the JSON file. What I want you to do is I want you to copy the contents of that JSON file and overwrite this task-definition.json file in the top level directory. You're going to copy and paste and have these values overwritten. Save it, and we're going to push to the GitHub repo in a second, but not just yet. So you've updated the task-definition.json file. Great. We're using an AWS action created by AWS and Amazon, so we have to do anything with it. ID render container nginx. This is the one we're going to use to actually update the nginx container. What are we doing for container name? env ECS task definition container name nginx. Let's just see it for one of them real quick, right up here. That's what we have to match. We have to specify that. Login ECR, the same one we used before for the build tag and push, just coming from right there. Great. ECR repository name nginx. Great. And the image tag. Great. So that's how we're able to update this. And we see this render container nginx. We see this reference right here for the task definition. The reason we're doing that is because right here contains multiple task definitions. You have to specify the updated image URIs from the ID of the previous one. And you can reference that right here to see why we have to do it that way. So we do that for Flask. We do that for RabbitMQ, Celery Worker, Celery Beat, Celery Flower. Great, so we updated all 6 of our containers in our single task definition. The final step is to deploy to Amazon ECS. So we actually take our ECS service, we tell it to pull the updated task definition, and then we actually update our service. You'll see we're referencing the last ID of the last container that we updated right here. That's how we have to do it. Again, reference the previous one I mentioned before. And also I'll just mention right here, the set target group deregistration delay, the thing we specified in the previous videos. If you go to your target group, you go to attribute, you should set this deregistration delay to something smaller, like 5 seconds. By default, it's set to 300 seconds. This means if you try to update your service, it's going to take 300 seconds, 5 whole minutes for the first one to deallocate and the second one to come up online, which is a long time. You don't need to wait that long. I set to 5 by default. And this wait for service stability set to false. This just means that when you run the GitHub action, it won't wait for the service to be stable before ending. For one container update, service update, it's probably not a big deal because you could just wait for the GitHub action to finish. It actually lets you know that the service is online. But when you have multiple ECS services you're updating in a single file, you definitely want to set this to false because that means if it's set to true, you have to wait for the first service to finish updating, and then it will try to update the second service and instead of trying to update them all at once. So definitely recommend setting this to false. Okay, so that's the AWS ECS deploy file. Great. Here's task-definition.json we just updated. Great. We're going to push that in a second. You have to go to nginx.conf now and modify these two values because we're now pushing directly from GitHub to AWS ECS. So we have to use the value we need to use localhost when running on ECS. We can't rely on the URL we're using when we're running locally on our desktop. So we have to change these two values right here. Make sure those are set. The final thing I want to do is just set this hello world to hello world 2. Why are we doing this? Just so we can easily see the change and see it's applied and make sure we know that's working fine. Okay, so we're going to go to our repo. We'll do git status. See we changed 2 files, nginx.config. Yes, because we updated the URLs, and project app.py because we just changed it to hello world 2. Great. Now, one other thing you should see is the task definition.json. So you actually see 3 files here. We're going to do git add star, git commit -m, update to push to AWS ECS from GitHub Actions. You can call it whatever you want, and git push. Great. You see it's push. Let's go here. We'll go to Actions right now. We'll select the AWS ECS deploy, and we'll run the workflow. Great. Give it a quick refresh. We'll see it's running. We can click into it, and then we'll see it running. I'm going to go ahead and fast forward the video when this is done running. Okay, finished running. See, it took about 59 seconds. Might take more for you because I already have the ECR repositories pushed, and I'm not pushing stages. I've already had the stages repositories built as well. But let's go to ECR real quick. You click a quick refresh. You should now see 2 additional repositories, -stages. Again, these will speed up subsequent builds and future runs of that GitHub action. Going on, go to ECS. We see our task. We see one that's deactivating, one that's running. Great. Now to actually access our application, go to load balancers. The way you do that is EC2. Scroll down the left, load balancers. Click your load balancer, and then get the DNS name. Just paste in the browser, and then you'll see Hello World 2. Zoom in a little bit. Here you go, Hello World 2. Great. So we see it worked fine. Now, if you have any issues with this, say it's not loading, it's not resolving. First thing, check the security group. Make sure you have port 80 open for your IP. Second thing, go to the ECS service, go to logs, any container, and see if you have any logs that are saying what's going wrong. It's not easy to read because there's a lot of errors going on. Go to task and scroll down to which container is failing. It should say specific one is failing or having an exit code, and you can go back to your logs and pick which container you want to actually look at to get more information about why it's failing. Okay, with that being said, we now understand how to push automatic updates of our application using GitHub Actions. Great. The last and final video in this video series is going to be using AWS CDK, Cloud Development Kit. What this does is allows us to automatically create all the networking setup we did in the production ready video series and all the ECS components as well that we did in the production ready series and the get it ready series. We have all that created automatically. You don't have to go to the AWS console, create the VPC, create the subnets, etc., etc. You're going to have it all set up statically in a script file that we can run automatically. The CDK script, Cloud Development Kit script, is going to be written in Python. It's probably the most powerful video of the entire series, to be honest, because not only does it allow you to deploy this AWS application on ECS with Flask, Celery, etc., nginx, all that good stuff, it automatically has it all predefined in a set script to automatically create it for us. So this not only allows us to have it ready and have it deployed quickly for ourselves, we can share this file with someone else and saying, hey, here's my build template. Do whatever you want with this. This is what you can use to build yours. So it's very easy to use in an organization. If you want to have standardized setups and teardowns of applications, you can use this Cloud Development Kit script very easily within an organization to have it much more standardized. I do really recommend watching that video next, and I really think you will get a lot out of it. So, as always, I hope you learned a lot in this video. If you're having a lot of success watching these videos and learning a lot from them, send me an email. Let me know. Just leave a comment below. I really like hearing these stories of how people are benefiting from these videos I'm making. And yeah, stay tuned for the next one, and I'll see you there.